I just want to introduce you to rationalizing the denominator. If you go back to the other video where we talked about simplifying radicals, it says the process of eliminating a radical from a denominator by multiplying the radical expression by a appropriate value of 1. So let's talk about what that means. Remember, to be in simplest form, you cannot have a radical in the denominator. So if I am to simplify the square root of 5 over 2, I can write as the square root of 5 over the square root of 2. Except we have a problem because we have a radical in the denominator, and it's not a perfect square, so we can't get rid of it. So we're going to multiply by 1. Except I'm not just going to multiply by 1. I'm going to multiply by the square root of 2 over the square root of 2. Here's why. This is equal to 1 because it's the same thing on top and bottom. And what happens is I end up with the square root of 5 times the square root of 2 on top. But let's look at the bottom here. And actually, I want to write this as the square root of 5 times 2. Kind of put it back together. On the bottom, I have the square root of 2 times 2. That gives me the square root of 10 over the square root of 4. And if you're thinking, well, you still have a radical in the denominator, you're right. Except, notice it's a perfect square. This ends up being the square root of 10 over 2. Because the square root of 4 is 2. If you look at the square root of 10, does it have any perfect square factors? 1, 4, 9. With the exception of 1, no it doesn't. So that is your answer in simplest form. I know it seems kind of weird, but it's just something that's how we rationalize the denominator. If you're trying to get rid of a radical in the denominator, just multiply the top and bottom by that radical. Because again, this is like multiplying by 1. You're not changing the problem. Let's try it with this one. We can break the square root of 2/7 into the square root of 2 over the square root of 7. We cannot get rid of the square root of 7, so let's just multiply by an appropriate value of 1. The square root of 7 over the square root of 7. Up top, that's going to give me the square root of 14, and 7 times 7 is the square root of 49. Don't forget that it's still the square root of 49. And then we can say, all right, does 14 have any perfect square factors? No. So we're going to leave it as the square root of 14. But on the bottom, we're going to say, all right, what's the square root of 49? 7. That's our answer. Let's look at this next one here. We can break that down into the square root of 16 over the square root of 12. Now in this case, the square root of 16 excuse me, is a perfect square, so the square root of 16 is 4. Let's look at the square root of 12. Before you jump to rationalizing the denominator, although you could and then simplify after, I'm going to say what perfect square goes into 12? Well, 4 does. I can write this as the square root of 4 times the square root of 3. Because 4 times 3 is 12. Let's watch what happens. This ends up being 4 over 2 square roots of 3. 2 goes into itself 1 time, 2 goes into 4 2 times, and we have 2 over the square root of 3. Now, to get rid of that radical in the denominator, we want to multiply both the top and bottom by the square root of 3. On top, it ends up being 2 times the square root of 3 over, well, 3 times 3 is 9, which gives us 2 times the square root of 3 over the square root of 9, which is 3. And because we can't simplify that anymore, meaning we can't reduce 2/3, we have no fraction underneath the radical, and we don't have any radical sign in the denominator, that's as simple as we can make it. Okay? So again, rationalizing the denominator, I just wanted to introduce you to it in case you hear of it in the future. And all it means is to get rid of a radical in the denominator, you multiply by a form of 1. In this case, whatever the radical is, over itself.